Welcome to today's video with Chef Chun. Today we're going to be showing you all the physics of making a sandwich. First things first, after washing your lettuce, you must prepare to slice it up. In order to do that, you must exert work on the knife to lift it.
What's this for? Okay. 13.5 inches. Theta is 0. Gravitational constant 9.8.
The equation to find how much work you apply on an object is the force you apply times the distance times cosine theta. You find the force by using a balance to measure the mass of the knife. You then use the gravitational constant of Earth, which is 9.8 meters per second, to find g. Then you measure the distance of how far you lift the knife. Theta is 0 degrees in this situation. What is? Oh, that's the tape.
This is the tape. That's good enough, right?
What are the units for
Newton?
work?
Quick, look it up.
Work units. Oh. Joules.
Joules. J.
Calculate the measured numbers to get work, which is 0.551 joules.
Yay.
When cutting a piece of lettuce with a knife, the knife will not move past the cutting board. The knife exerts a force onto the board, and the cutting board exerts the same amount of force back onto the knife.
Yippee!
In my kitchen, we drop the food onto the plate of the customers. We use the mass of the sandwich and the gravitational acceleration to find net force acting on the sandwich, which equals 1.64 newtons. In my kitchen, air resistance is negligible. Only inferior kitchens have air resistance.
Perfect. Using the conservation of energy equation, energy initial equals energy final, we can find the final speed of the sandwich. We find the mass of the sandwich from the scale, the gravitational constant on Earth, and the height from the slow motion video of the chef dropping the exquisite meal. Deriving the equation to solve for the velocity and plugging in our values, we found that the sandwich had a speed of 3.46 meters per second.
Very nice!
Why do I want to eat this sandwich? Whoa! To calculate the distance the sandwich will horizontally travel, we can use the projectile motion formulas. We can use change in height equals 1 over 2 times acceleration times time squared to calculate how long the sandwich will be soaring through the skies. We know that change in height is 0.95 meters and the acceleration is 9.8 meters over seconds squared. Plugging these into the equation gives us time equals 0.44 seconds. We can use this slow motion video to calculate initial velocity with change in over x over change in time, giving us 1.45 meters over seconds. We can use this and time flying to calculate the sandwich traveling 0.64 meters. The actual distance of the sandwich traveled was 0.61 meters, leaving us with only 4.7% error. Phew!
Time to cut the sandwich. Here you go, customer.
Thanks, chef!
I wonder what the center of mass of the sandwich is.
To calculate the center of mass between three different objects, we will need to measure the distance from the origin and the mass of each sandwich piece. We measure the masses and distance of the x, y, and z plane of each colored sandwich, and we use the center of mass equations on each piece, which is the distance of the piece is to the origin times the mass of the piece over the overall mass. Repeat that for each piece. After plugging in the measured values, we discover the center of mass is 0.13 or 28.19, all in meters. This is about where the center of mass is.
Good sandwich.
Welcome to today's video with Chef Chun. Today, Aiden! No, keep it running. You can keep it running.
The mass.